I'm going to briefly describe an interactive simulation. This plots the Gibbs free energy versus mole fraction for a binary mixture. And the idea is that we can have one or two phases present depending on the Gibbs free energy value. So the simulation is located at the link given here on the LearnChemE site. And this is a snapshot that we have a condition where we have excess Gibbs free energy. So what that means is we always go to lowest Gibbs free energy. So if I draw this tangent line between these two minima, you see a point here has a lower Gibbs free energy. So what I mean is, if I were to pick a point here, this mole fraction, we have a lower Gibbs free energy by having a mixture of this phase and this phase instead of having things completely miscible. And so on the right is this represented as two phases. The areas are proportional to how much of each phase, and the mole fractions are given 0.85 for one phase and 0.07, this one here, for the other phase. And so this plot of Gibbs free energy versus mole fraction is a function of temperature. Let's look at the interactive simulation and see how it behaves with temperature. So I can pick a mole fraction. That's the black dot here. And it corresponds to these two mole fractions and represented on the right by the amounts and their mole fractions are given. If I raise the temperature, now this plot changes. The mole fractions change, and then the relative amounts of each phase change. And you'll notice as I keep raising the temperature, basically these two immiscible liquids start to become more soluble. So that we'll reach a point where now we only have one phase. And so we have complete miscibility because lots of liquids, the two components are more miscible at high temperatures, and so there's no phase separation. And so we always go to the lowest Gibbs free energy. If I lower the temperature, then I'm going to get two phases. If I change this point here, then you can see the relative amounts of each phase changes, and that's just calculated from the lever rule. These simulations have directions that talk about what I just showed you and also have details about the calculations.